Hi everyone, today I'll show how to use metadata to automate data quality validation in data-intensive application. I am Mu'min Abu Zaleh, Assistant Professor and IoT Unit Director. Data-intensive application depends on data quality for success. If single column, drift, or timestamp silently changes to a string, then dashboards break and model degrade. In practice, we keep seeing the same issue like missing value, inconsistent format across pipeline, duplicate records, and the most painful is schema drift after a. The challenge is that many teams still use manual validation rule. Writing these rules take a lot of time and it is easy to overlook detail in large schemes. Additionally, this rule can become outdated. Any change to the schema require more edit and can lead to mistakes. This is the gap we target. Make quality enforcement adapt to schema speed without handcrafting code every time something changes. 110 and 100 rule say spend 1 on prevention, 10 on correction, or 100 on failure. In data term, we say generate check up front or pay 10 times more to rework pipelines or 100 times more when bad numbers hit a decision. Our approach move us into prevention zone. We rely on data quality useful tools like Great Expectation, DQ, DBT, and SODA SQL. However, these tools need a lot of manual setup. Engineer have to list the column, choose the expectation, adjust the threshold, and keep everything updated as data structure is changing. This leads to three main issues. Limited automation even with templates, poor adaptability changes like new column or rename field, inconsistent coverage, different teams use different code, which lead to inconsistent testing across both important and minor columns. Our approach streamlines this by automating rule generation from meta model, ensuring systematic coverage and quicker adaptation to changes without the need for manual or code. Our framework act like compiler. You provide metadata, we create tests. We begin by examining data source. Instead of pulling dataset, we read the schema through the catalogs or data definition language. The meta extractor extract information about tables, column, data types, constraint. Next, data quality dimension. We link data quality dimension like completeness, accuracy to schema element. We set default but allow for human adjustment of mapping or threshold. In code generation, we convert each quality dimension into specific check in great expectation, generating clear Python code with a great expectation code. This code will be ready to review and execute. Finally, in monitoring, validation creates reports and alerts to Slack or email and track metric. Each failure is traceable to the specific column and rule. Our framework has three main parts: meta extractor, quality rule mapper, and Python code generation. First, for meta extractor, we don't scan data. We read schema from catalog or house tables, column types, constraint, and keys, foreign and index. This gives us a reliable picture of what should exist automatically and repeatably. Second, the quality mapper that map data quality dimension to list of predefined great expectation like from completeness to the list of predefined great expectation. Third is a code generation. Code generation is a parameterized template render clean deterministic great expectation script organized by table, version controlled and ready for CI/CD or nightly run. The output is a standard great expectation. So team keep their existing store, report and alerting. When the schema changes, we regenerate and the check stay in sync. In this slide, we show the main element of metadata that extracted from the data source, like table names, index definition, data type, foreign keys, column constraint, primary key, and column name. But why we convert to Great Expectation? Great Expectation is an open source Python library, has more than 50 expectations, 16 data sources, 5 orchestrator. What you are looking at is the template layer that turn metadata into runnable great expectation code. We start from placeholders uh, like schema name, table name, username, password, and expectation field like expectation method, expectation parameters. At generation time, framework fills these from the catalog. The result is reliable, changeable Python code that uses great expectation that automatically update when the schema changes. It takes in metadata and produce executable script. This is a live great expectation report produced by running the generated code. We are validating the column act stop time with a not null rule. For simplicity, we implemented a simple user interface using Java forms. We evaluated our framework using ISP, the data from ISP, the full schema and data are uploaded. The data set has at least 7 tables with very different scales. With great expectation, we move data quality to prevention. Script setup drops from days to minutes. Weekly effort falls by about 60%. For the future work, we try to cover more domain like healthcare, finance, and we are trying to reduce or to eliminate human intervention. Thanks for listening. I'll be happy to accept and answer your question.